Näin päin varmaan parempi.
Hello. Yeah. Good day, everyone. So this is the starting of the Energy Forum lecture series. Today we have Jussi Jyrinsalo from Fingrid presenting the challenges of the management of changing energy grid, electricity grid, and for all of those who don't know yet, so this is a series of 12 lectures spanning the whole fall semester, and we are having industry participants presenting their expertise. And we would like you to be very active and present questions and challenge whatever you're presented with. We have time in the end of the lecture, but also if you have something, just ask straight ahead. And yeah, go ahead, please.
Okay. Thank you. And I guess you can hear me quite well now. So, as said, my name is Jussi Jyrinsalo and I come from Fingrid, the National Transmission System Operator of Finland. And I'm in charge of grid planning and grid services towards our customers at Fingrid. So I'm the head of a department where we plan the grid and then we also sell the transmission services. And in the beginning I will tell something about Fingrid, a couple of words, what's our area of responsibility and how do we affect our customers and the society at large. Then I will jump into the changing electricity system, what kind of challenges it poses for the transmission system operators, how to manage the future grid, and then in the end we'll have a couple of words about the competencies needed by the engineers who try to solve these challenges. So 3 parts basically. And feel free if you have any question when looking at the slides, you can ask those questions right away, or then if you want to save them till the end, anything goes with me, no problem. So let's start with Fingrid. So basically people usually think that a TSO like Fingrid, that's a company who transmits, but it produces over here different types of sources for electricity production. Then it's the transmission system operators transmitting the electricity to be used directly in some consumption or then through the local distribution grids towards the end consumer. But in addition to this role, we also take care of system operation, so keeping the lights on in the system. Every TSO in Europe at least has this so-called system responsibility. So it's our job to take care of the electrical power system, create such rules that it operates constantly and it can be balanced every second. Then what has during the recent years has been strengthening is the development of electricity market. So TSOs, transmission system operators, have quite a big role in developing the market rules also, so that the market can reflect the actual situation and the demand and the production can meet at every single second and every single minute. So those kinds of activities are also done by TSO. So developing the market rules, developing the markets. So basically this thing, the traditional thing, transmitting energy and then operating the system and developing the electricity market rules, those are the main tasks of Fingrid. And this picture kind of says it all. What's our business model? What do we do? So on the left-hand side we have the resources. What are we putting into our machine? We have personnel, we have suppliers, we have financing. There are many things on the left-hand side. And then in the middle you can see our main processes. So we take care of the adequacy of the transmission system, which means we plan the grid, we build the grid, and we maintain the grid. So asset owning is this part, taking care of the assets. And for example, Fingrid has some 14, or now it's already 15,000 kilometers of power lines and some 130, I would say, substations all across the country. Then system operation means we plan the operation of the power system, we monitor and control the power system, and then if we have some disturbances, we manage them efficiently. And then the third process is how to promote the electricity market. So harmonizing the rules, increasing the transparency, creating the market in such a way that all the participants have the same possibilities of operating at the marketplace. And then we create, or we have some services for our customers, transmitting electricity, balancing the system, exchanging some retail market data, and this will become, in a couple of years, this will be called Data Hub. So all the metering information from every household and every location in Finland will be collected in one place called Data Hub, and that will be operated by Fingrid. Then we publish some wholesale market information for the market participants to use, and then we give these certificates of origin. If somebody says that I have produced this and this much of renewables, or used this and this much of renewables, we give a guarantee that it's really done. We look at the meterings, the meters, and give a guarantee of that. But then the impacts to the society, they are usually much bigger than the value for single services. For example, if one of our transmission lines towards Sweden is stripped, the effect it has on the whole of the society is quite big. The Finnish electricity price jumps up, and everybody in Finland pays this extra price. So the impact we need to think quite a lot of when we plan our operations. It's not that we just optimize our own costs, for example. We need to think what are the costs to the whole of society. And for example, the DC connections, the high voltage direct current connections we have towards Sweden, we have put a lot of emphasis on repairing those very fast in case we have some disturbances. It may cost us quite a lot, but then again, the society at large saves a lot of money. Okay, and then we set our targets so that it's a balanced structure. This is basically built on the, what do you call this, balanced scorecard approach. So all our targets are set so that we think of the customers and society, we think of the owners, we think of our internal processes, and then the personal view. And then we balance these different approaches, and then we set our targets according to this. So we are not only looking at our own processes, but we are trying to optimize our operations based on these targets. And the way we manage our company is so that we have a matrix organization, and all the targets are set by these headlines, not the names of our departments. All right, that was some words about Fingrid. And as it comes to the company size, we are some 350 persons, so quite a small company. Most of us are located at Helsinki, but then we have outsourced very much of our activities. So I would say that every day some 1,000 people work for our company in one way or another. And what else? Our yearly turnover is something like 600 million euros. So 400 million comes from the transmission business, so selling transmission services for our customers. And then the rest comes from these other services I just showed. Okay, so that was something about the company, but then let's dig deeper into the energy system, how it will change and what will the challenges be in the future. So the electricity market, basically we have a market at least on the Baltic Sea region. So we have power exchanges operating at this region. But nowadays also the whole of the Europe is connected so that the different electricity exchanges they cooperate in such a way that the price formation in the whole of the Europe is done in the limits of the transmission capacity, I would say. So basically, the electricity market is much wider than the Nordic countries. It's at least Baltic Sea region, but little by little, it's the whole of Europe where the price formation happens. But this is the situation at the wholesale market. Of course, the retail market is then another thing. Can I buy something from Portugal? That will take some time yet, but the wholesale market will be like this in the near future. But then as an electrical system, the Nordic countries form one entity. So we have a synchronous power system. So every generator every synchronous generator running in the system, they operate in phase. So in case one of the generators drop, so it has some fault in it, all the others help instantaneously based on the frequency. So all the generators see the same frequency. They oscillate because of the same frequency, and they help each other. And then you can start exchanging reserves and making the best use out of your system. So of course the systems could be even bigger, but then you have lots of electrical problems, how to manage you have lots of stability issues, all other kinds of issues. So at this point it seems that the Nordic system at size is quite, you cannot make it that much bigger, it becomes too complicated. But anyway, as an electrical power system, we Nordic countries, we have joint rules for how we control the frequency, how we operate the grid, how we plan the grid. And all is done in such a way that the system in at any situation it can withstand any fault. So any one of the big power plants, any transmission line, any bus bar in our substation may be faulted and nobody sees it. So the system is N-1 tolerable. So you can lose one component at a time. And then in 15 minutes you need to get the system back to such a state that it can tolerate another fault. So you have all the time you have 15 minutes to adjust. And that's the basic principle how the system is used. And this usually gives quite a nice level of system security. So the system is quite tolerant against faults because usually you don't have many faults at the same time. It's usually only one fault. And the possibility of having several and many difficult faults at the same time, that's pretty low. So this N-1 principle usually gives you enough security. Okay, and this is something about the frequency of the grid. So frequency indicates is there a balance between the production and the consumption. So if there is too much consumption in your system, then the frequency goes down. So you have too much load at the generating machines, the synchronous machines, and they start to decelerate. So, and vice versa, if you have too much generation in the system compared to the load, then the frequency goes up. And then you need to balance the system every minute and every second. So there's a balancing market for doing some slower adjustment, and then there are reserves for doing fast adjustments in case of a fault. And basically the electricity market parties, they balance this themselves, but that they can only do in a certain time frame. So we as a transmission system operator, we need to have some reserves also for the faster disturbances. And all of the reserves we buy, they are bought from electricity market parties. So we don't have our own power plants which could be activated. Well, actually, I'll come back to that. But most of the reserves are bought from the electricity market. So we buy, let's say, some hydropower plant. We buy a little piece of their production capability and then they reserve it for us to be used in case of frequencies. But why I said I will come back to this is that we own some of the gas turbines in Finland. Let's say, is it some 80% of the gas turbines, because we are a single buyer for that kind of capacity where you ramp it up in 15 minutes. And experience has shown that this is the most cost-effective way that we own most of the such a capacity. Okay, that was some basics about how to compensate or how to balance your system. And then what are the challenges of the future electrical power system? This is the situation in Nordic countries. So there are people closing, or power producers are closing their thermal power plants because the energy price is such that they see that it's not worthwhile anymore to have these old thermal power plants in use. There is so much subsidized, let's say, wind production and little by little maybe also solar production that the thermal power plants are little by little they are vanishing from the system. Then the share of wind power is rising, especially in Sweden, in Denmark. Then the nuclear plants in Sweden are decommissioned earlier than initially was planned. And then there will be lots and lots of new capacity from the adjoining systems. So from Nordic countries, there are plans to build new lines to England, to Netherlands, Poland, Germany, maybe some new lines to Baltics also. So more and more of interconnection capacity between the Nordic system and the rest of the Europe. And that's worthwhile from the economic point of view because still our system is very different from the European system. We are still hydro-dominated system, so lots of hydropower production, and it's sort of a battery. You can control it up and down, and it can act as a reserve for the rest of the system. And that's what the continental Europe was very interested about, using the hydro reserves in the Nordic area. But anyway, these are the big things happening in our system. And what happens then? There will be more and more changes. So earlier it was so that when there was lots of hydropower available, so lots of raining and so on, then you had lots of hydropower up here. And then that replaced its thermal power at such point when you had the hydropower available. And then when you didn't have the hydropower available, then you used the thermal power to compensate for that. So the changes were maybe seasonal. Maybe some years were drier than some other years. But anyway, the changes occurred quite seldomly. But the new system, you have daily and hourly changes. So up here you have hydro and wind power. In the middle of the system you have thermal, hydro and wind power. Then you are tightly connected to the other parts of the Europe where you also have lots of solar power. And this thing, every hour there are changes. But electrical power market always tries to find the cheapest production source out of this system. And whenever there is enough wind or solar, that's the cheapest. So it tries to push itself to other parts of the system. So lots of more fluctuations in the operational situation than it used to be. And what does that create? What kind of challenges comes out of that? First of all, we need more and more flexibility from our system. So you have many interconnectors, the power of which is fluctuating constantly. Then you have wind power, you have solar power, it's fluctuating up and down. So there must be something in the system balancing for this. So the rest of the system needs to be flexible enough. And the need is going up, more and more flexibility is needed, and then as you are losing the thermal power plants little by little, the available capacity for your flexibility is decreasing. So the equation doesn't look too good. Then the adequate generation and transmission capacity to ensure the security of supply. You have lots of energy in your system. So you have built lots and lots of new wind power plants and solar power plants, but then you have lost some thermal power plants. And in the end, you cannot guarantee that every hour you have enough production capacity in your system. I will come back to that. But the adequacy issue, that's something that's going down, so it's becoming worse. Then a more technical thing is inertia. So inertia is the kinetic energy that's stored in the rotating masses of the synchronous generator. So if you deviate the system in a way, you have a large disturbance. Your machines don't stop immediately because you have lots and lots of masses rotating. Let's say a large nuclear power plant. It's a very big axis full of things rotating over there, so it doesn't stop immediately. So this gives you some tolerance towards faults in your system. But now as the rotating, or these synchronous machines, big machines rotating, they are little by little replaced by solar power, which don't have any rotating masses, or then wind power, which have less rotating masses than the traditional generators. Then your inertia is dropping, and that gives you some problems in the future. And then the constant changes also of the power situation affect the frequency quality. So your frequency is not that stable anymore. So those are the four main challenges we have identified at Nordic countries, and I guess those are quite the same all over Europe. So those are the things we need to take care of in the future electrical system. So let's then dig deeper into these one by one. What do I mean with this challenge and how to solve it? First of all, flexibility. So, as I said, the flexibility provided by these existing synchronous machines, that's reducing in the system. But at the same time, more and more flexibility is needed. And what happens, the price formation gets more difficult in some hours. The demand and the power production do not meet, so the price jumps up. You get very high price peaks in your system, and maybe you don't even have any price at some hours, and then you need to start some reserves and try to compensate your system in such a way. And there might be problems of having the price formation in the day-ahead market, so the market that operates one day before the actual trade is done, or then inside the day where you are using these balancing resources, or intraday electricity market. And how is then this flexible capacity ensured? You must have enough market signals so that people start building some flexibility in the system. And how will that happen is that the price really rises up. For the politicians, it's very difficult to, they don't really want these kind of peaks in the energy price. So people subsidize production and try to make it work so that you don't see the spikes. But actually the spikes are such that somebody starts to invest. If you can earn some money out of the spike, so why not? So let them show, let the price fluctuate, and that will little by little make your life easier, and you get some flexible capacity. Then the generation adequacy. So do you have enough generation every hour of the day, every minute of the hour, every second of the minute? And this is a picture how you have, at 2010, you had this much of thermal power in the Nordic system, so some 33 gigawatts, 33,000 megawatts. And then this is the amount of wind power. And this is the estimated figure for 2024. So if you add these two bulks, you get more gigawatts than earlier, but still, during peak periods, you don't have the balance. The balance was positive here because all this machinery was controllable. You could ramp it up when more power was needed. But now this part was controllable, but now there is this part that cannot be ramped up. And there are some hours where you don't have enough capacity in your system. And this is something that we, transmission system operators, we cannot solve it ourselves. So there must be an efficient market framework solving these problems. We can of course build more lines to the adjoining countries, to the adjoining power systems, and then hope that the adjoining system has enough energy at a certain point when we are lacking it. But still, there needs to be a market that really makes the electricity move from one place to another. And any kind of state aid rules, if in some country somebody aids some type of production some national legislation, they make it harder for the market to operate and find the optimal solution. So these are the things that need to be done in order to solve this adequacy issue. And as it comes to adequacy, ENTSO-E, which is the it's actually European network of transmission system operators for electricity. So all the transmission system operators cooperate through this platform. We have done some studies of the future, and here are some estimated situations for 2020 and 25. And the hours shown here, it's very small, but I hope you can see it. Those are the loss of load expectations. So how many hours in a year the generation and the import cannot cover the load in each of the European country. And 2020 estimate is such that Poland is the worst place. So I'm not sure about the color, but it's some tens of hours that you don't have enough generation and import to cover the load. Then Northern Ireland. What one is this? Is this Romania or Bulgaria? If somebody knows, please help me. But one of these countries down south. And then Finland also. So it doesn't seem too good for Finland. So we are heavily relying ourselves on import. And if we have a tough situation, we have one big nuclear power unit or one single power line, one connection towards Sweden, we have that out of operation, then there is a certain probability of loss of load hours, so we don't have enough capacity to cover for the load. Of course, the megawatt hour figures, the energy that is lost, it might be still small, even though you have some hours. It's not that you lose all of the Finland. You may have to have some brownouts in some part of the system to solve the problem, but it does not mean that the whole of Finland is without electricity for this amount of hours. It might be a small part, but you need to be able to control it, to rotate the brownout throughout the country so that it doesn't affect too much the everyday life. But 2025, this is coming worse. So same places, Finland, Poland, still quite dark over there. But as you can see, also France, Germany, Benelux countries, Great Britain, so many southern part of Sweden. So the adequacy issue is rising all over the Europe. So something needs to be done to take care of this. And of course, if you can find a way to store electricity in an effective way, that's the solution. You have lots of excess energy, let's say during summer days, and if you can store that and then release it when it's needed, that's the solution then. But so far, only the hydropower plants are the ones being able to store energy in a very large scale and over months and years. But maybe someday there will be a technical solution for this issue. But what again makes it easier, if the price really indicates the situation and then the price gets higher, of course somebody starts building new power plants and then problem solved. But the price must steer. All right, then how we plan the transmission capacity then. How much capacity is needed between areas and between countries? The planning starts with this N-1 principle. So in every estimated situation, you need to have enough capacity to tolerate any fault in your system. And as it takes at least 10 years to build any new line to your system, you need to start early enough, build different scenarios, try to simulate how will things look like in these scenarios. So we have so-called market simulation programs. So the simulation program knows what kind of power production is available all over Europe. Then it starts to optimize. It tries to find the cheapest way to produce electricity for every hour. So it sort of expects it to be an optimal market where always the cheapest one wins. And then based on that optimization for every estimated future, every hour of those years, future years, then you see the transmission patterns, how much electricity you need to transmit from one point to another. And then you try to make it N-1 tolerant. So then you start testing faults against your system. Does it tolerate all these faults? And then you suddenly find that I need this and this line to make it happen. And currently the grid planning is done at many levels. So at European level, there are in Brussels people try to simulate the whole of Europe. So what are the transmission needs throughout the Europe? Then we are operating at Baltic Sea level, Nordic level, to look what is do we have anything to add to that equation, and what are the solutions needed from us? And then also we have national grid planning, where we discuss with our customers what are their needs. But anyway, grid planning has become little by little very international thing. It's not only planning your grid inside Finland. You need to be part of the bigger picture. And now we can monetize the market benefits, so we can easily see how much value does a new line create for the electricity power market. That can be done by the present analysis programs. But what is still missing is what is the security of supply benefit? How much does the line help your security of supply, and what's the value of that? That is something we are working on, how to monetize that thing. Okay. Then one of the challenges was this animal called inertia. And as I told, inertia is the rotating mass of the synchronous generators. And this picture shows where are the rotating masses located in the Nordic system. And most of it is in southern Sweden and southern Finland. And the explanation is that the nuclear power units are they have lots of inertia in them. They have big axis, lots of things rotating around that axis. And they really help in having some kind of, or having enough fault tolerance in your system. But this figure, especially if Sweden closes down the nuclear power units in southern parts of Sweden, this figure will drop quite a lot. So your system isn't that tolerant anymore towards faults. And then what does that mean if it's tolerant, not tolerant anymore? It means that if you have a large fault in your system, let's say you lose the biggest power plant or a big transmission line, then your frequency will go down very fast. And there's a possibility that you don't have enough reserves to stop that frequency decline. And then it's a blackout in some area. So somehow you need to be able to tackle this very fast changing frequency. And of course, one thing that can be done is to limit the amount of power that is produced in a single power plant. So let's say you have a large nuclear power unit, then if it would create too much problem when it trips, when it's faulted, then you limit the power. But then again, you might have some adequacy issues by doing that. So that's maybe not the only solution that works. So maybe in the future, some batteries can provide such thing that they can help in these fast changes. They can push a lot of power to the system at the right point and very fast, and help in restoring your system frequency. So on the right-hand side, there is a picture. I cannot even try to explain what is this thing over here. But anyway, we did a Nordic study, and somebody very clever put it in that way. But the end result is that in 2025, it seems that some 8% of the hours of the year, the system cannot anymore tolerate the tripping of the largest unit. So there is quite a big probability for the system having too less inertia. So something needs to be done for this. And as said, batteries might provide one solution. So very fast reacting batteries that can push some active power to your system in case of need. Maybe some rotating masses all over your system. You don't produce any electricity, you just rotate a power plant. It doesn't sound too wise, but if that needs to be done, then that's it. But this is a very technical issue that needs to be solved in the future. And then the frequency, I was now, in the previous slide I showed that the minimum frequency, if you don't have enough inertia, that's the problem. But also how to maintain, in your everyday operation, how to maintain a decent level of frequency. Because your system is changing every hour, every minute. And then you have to have enough reserves to balance for that. And this picture shows the frequency quality of the Nordic power grid. It has been declining during the recent years. because the system is affected by more and more changes. And we need to find ways to find new reserve capacity, new type of technologies to fast react and counteract the frequent changes. All right, so those were the challenges and some ideas how to solve these, but we are still trying to find many of the solutions. But how then to manage the system? First of all, that in the European scene, it is seen that it's not enough to control the Finnish grid anymore, or even the Nordic grid anymore. You need to do it on a higher level. And that's why we are now starting these regional security coordinators. So in the Nordic countries, we will have in Copenhagen this unit that is joint for all the Nordic countries. So some high-level supervision of the grid. So this Nordic RSC will help the TSOs by taking part in operational planning activities, when you can take out the line, when not. Then they calculate the cross-border capacities throughout the system, and then they do also outage planning for the interconnections between the countries. So you need to be able to manage your system on a higher level, because the system is more prone to faults, and you need to be able to control it. And there are also other security coordinators that are being put together in Europe. So Coreso is this one. So they are trying to operate this thing all together, and then TSC net for this area. Then you have some operations over here. So this is one thing, to add one layer how to control your grid, to make it on a higher level. You might one day have some European unit for running the system. But this is still only technology. If the problem is large, it's not any use of adding some organizations. So what is the basic thing that needs to be done is, first of all, to create a large market area and strong infrastructure so that Norway can balance Finland when needed, Finland can balance Norway when needed, and this can be done on a very, very wide area. So, and the market is joined for this large area. That's one part of the solution. Then we should have real-time markets, so the energy price is created for a shorter time frame than nowadays. Now it's 1 hour, and maybe in the future it's something less. And you need to have enough incentives for balancing your electricity production or electricity consumption. So the price needs to indicate, and you need to have enough incentive to balance yourself. So that kind of market is needed. Then consumers need to be put at the center so that price steers all the consumption. And in practice that means that every household at one way or another changes its consumption based on the energy price. Little by little there are some pilot projects where people are already controlling the, let's say, the electrical heating or something based on the power price. You add some smartness in your home. You have some box that knows the price and tries to control your household. So that's one of the new solutions to control your load, more demand response. Because you might not have enough production for every hour, so why not take the consumption down at some hour if during the next hour you can take it back. And then there might be new solutions for balancing and reserves. As I said, batteries, energy storage, that kind of stuff. I guess people will invent them any day because it's so big a business. Somebody will invent a way to store lots and lots of electricity. So also technology is part of the solution. But at the big picture, these are the solutions. If you are able to make these things happen, then I guess you are able to run your future electrical system also. All right, then finally, some words about, because you guys are studying here, you want to be good engineers, some thinking about that, what kind of engineers are needed in the future. So we defined our core competencies, was it last year or 1 year before that? And these are the set of core competencies we see at Fingrid. So this is the traditional one, knowing how the power system operates. What has traditionally been taught in universities. What's the theory of electrical engineering? What kind of equipment and components there are? How to plan your grid? How to maintain it? How to operate it? How to balance it? So this basic engineering knowledge. But then, of course, you also need to know how is it turned into business? What kind of IT systems you need, what kind of financing you need, what kind of service suppliers do you need, what do you provide for your customers? So this is the company level. So you add the company level on top of the know-how. Then you need to know how to behave, how to be a good expert, how to be a good boss for the expert. So these kinds of skills are needed from everybody. So you need to be able to discuss and find solutions, not only yourself, but involving more and more people and managing projects, that kind of stuff. And then this is getting more and more important. You need to have know-how on society. Why are we working here? What is the society? What is our customers? What are the stakeholders expecting of us? You need to be listening to different parties. You need to have lots of discussion. What are the goals? How should we solve them? You need to know how you affect the environment. You need to know how you affect the security of the society. So this is the big picture. These kinds of skills are needed. But of course, when you look at this, oh no, I cannot know everything. Of course not. It's not only one single person knowing all of this. So there are different levels of expertise. And in our company, we have this thing called specialist career path. So we have defined what is expected from a young engineer when he comes into the company. And that's mainly number one. You need to be able to solve problem by using your special skills. So your boss gives you some tasks. Please make a plan out of this. Calculate how much extra capacity is needed between point A and B and come out with a plan. Okay, that can be done by an engineer. But then the second level is you need to be able to develop yourself. You see some problems, okay, I don't have enough, let's say the IT system is not good enough for this purpose, or I'm lacking something. Okay, then I start to develop. I build up an R&D project or involve some other people, and then I set some goals and solve them. So I become more independent. Then the third level is that I'm combining already several skills for the above. And I start mentoring others. I involve other people's. Okay, we three, let's get together and solve this problem. And I know quite easily what the others know and what they don't know, and then I can use the others for solving the problem. Then little by little you rise yourself to the company level work, so you start to prepare some strategic plans, or then you are really stepping up. You are not an expert anymore, but you are sort of thinking the whole company, what are important things and how they should be solved. And then the final level is that you are able to lead the development in a certain competence area, nationally or even internationally. So these are the different levels, and we need people in each of these levels. And then we cooperate so that we have some people already up here, most of the people are here somewhere, and then we create matrices and we try to find good teams for solving many problems. But what all these needs is they need to be able to share knowledge, not only working by myself and keeping all the information on myself, sharing knowledge and also interacting with stakeholders. So it's not that you are just closed in your room and you solve the problems, but there are people calling you, and at least in our company we have opened up our expertise to our customers. So we have given a large set of names that if you have any problems as it comes to relay protection, please call these guys. So our experts are always exposed to our customers, and they need to be able to discuss also with the stakeholders. And that way we can also learn from the customers and they can learn from us. So we think it's very important to get the engineers up front to discuss with the stakeholders. Okay, so that was about the people making it happen. So now I guess you have some questions.
Oh, thank you, Jussi, for a very nice presentation. Any questions from the floor? Please.
One question about the Nordic grid. Is there any chance that Iceland would be part of the Nordic grid region?
Yeah. There are some plans to connect Iceland, but mainly to England. So I think that's the most viable of the projects people have planned. It will be the longest HVDC line there is, I can't remember the exact, is it 14,000, no 100 megawatts, 1,400 kilometers, so I guess. So currently the longest high voltage direct current line I know is 700 kilometers. So it will be double of that amount. But the energy is so cheap at Iceland, so I guess there will, at some day there will be profitability for such a line. But I guess it will go to England, not to Nordic countries. But maybe the next phase would be also connecting to Norway.
Please, there.
Do you have a lot of contracts with energy consumers? For example, if there's suddenly a big need that you need to consume more energy, then like some industry,
Yeah.
like some big transport or something like that.
Yeah. So industry is something we have contracts with. So in Finland, we use exceptionally a lot of reserves that we buy from industrial plants. So it's usually that they trip some part of the production process or something in case we need it. And then we pay them a yearly sum, and then we compensate for the loss that the tripping of the industry creates. But maybe in the future there will be aggregators putting together smaller loads, let's say some household loads, and then we buy some reserves out of these aggregators. But so far we have been cooperating with the large industrial power consumers. But in the future, I guess it will open up. We are able to reach each and every home via these aggregators. But we will not be making direct contracts with a single household, that's for sure. There needs to be somebody in between.
Seppo, please.
Seppo Brennus is my name. You mentioned the data hub in the beginning and
Yes.
which you are implementing, and if I understood it correctly, I mean, it's a huge ever-growing database to which the distribution or network operators are transmitting a smart data.
Yes.
Smart meter.
Yes.
Data. So could you elaborate that data hub a bit more? So what are the goals and then applications and what's the organizational setup and what's the time scale?
Okay. So currently all the metering data from your electrical meters at every home, it's connected to your local distribution company. They have this small data hub. So Finland is full of small data hubs. And our role, Fingrid, is developing all the standards for exchanging information and how the information should be gathered and that kind of stuff. But it's very difficult to really be able to control this thing with several small data hubs. And now the decision, we still lack the law actually that gives the task to Fingrid, but it will come in a couple of months, I guess. And then Fingrid will put together this very large data hub, and it collects all the metering information. And then what it's used for, it's for balance settlement. And then if you want to exchange power provider, then the national data hub is the place where this happens. So then it's easier for a certain consumer to exchange his power, the seller of the energy, because it's only one type of process in the whole of country, and then it happens via this data hub. And data hub is organized in a way that it's Fingrid's daughter company. And maybe in the future these data hubs between Finland, Sweden, Norway can discuss with each other if some additional value is created out of that. But it has so much information in it, so I guess out of that information you can create lots and lots of new businesses and whatever. Sky is the limit here. You have that much information in one place. So I guess it will help you a lot. You have lots of information about your system when you have the data hub in place. And the data hub will be operational somewhere late 2019 is the current timetable for that.
So, any more questions? Please.
Last year
Yeah.
regarding the rise of the renewable energy.
Yes.
So what is the situation right now in the report? Because you get some responses from the industry.
Yeah.
There was two paths that the market paths and the central control power system path.
Mhm.
Which one is like more favorable at the moment?
Yeah. So I think actually these things over here take quite a lot of say what we mean by what's the path we would like to take. And I think we get quite a lot of support from our customers also. So people do not want to go back to the old days so that the system is centrally operated and somebody decides on what kind of production is built and how it will be used. So our customers also want competition, and these are the things that needs to be done. So we got quite a lot of support for our ideas, and now we need to make it happen. But then we need some political support also. And they had this thing, I have no idea what is in English, but älyverkkotyöryhmä, smart grid, some working group, whatever. But the ministry has set that up, and I hope it will solve some of the practical questions that there are before you can jump into these real-time markets and every consumer participates, which are essential parts of our suggestions. What's a shame that on Nordic level we also would like to see this kind of development, but currently, as you have maybe read from the newspapers, there is a bit of quarreling between the Nordic TSOs as it comes to the balancing market. So let's try to solve that issue first before jumping again forward with the market development. But at least on national level we have this working group under the Ministry of Employment and what is TEM? What's that in English? Ministry of Employment and something. Yes. Anything
More
else?
questions?
Given all the problems that you have mentioned, do you think that all the current market measures are enough in the future to ensure all the adequacy, or would some, for example, capacity markets or something other be required to keep the markets up and so that the price signals go forward with ensure development?
Yeah. So if the time frame, the market becomes a real-time market, then I don't see any need for the capacity market, because real-time market is quite close to power already. So you are sort of paying for the capacity, but it's still an energy in one time frame. So, and then these capacity markets, they always create thresholds between the countries. So you need to harmonize them so that they don't create these thresholds between two countries and make the market non-functional. So I don't see that such a good solution. But what is definitely needed is the way to store electricity at some day. Without that, I don't think the future system will work. You need to be able to put electricity somewhere, make it into some other energy form, and then take it back at some time. So that's one part of the equation. You can play with these markets for some 10 years and so, but then I would really much like to see also the possibility of storing energy. And then all our problems would be much more easily solved. But nothing we can do. The technology is not yet there. You need to wait a bit.
There was one question.
Yeah. I think I read or heard somewhere that the grid could only take up like the loss of a power plant with the capacity of, I think it was 1,300 megawatts.
Yeah.
And now hopefully in the near future, if we start up the Olkiluoto 3,
Yeah.
which is the capacity is like 1,600.
Yes.
So what then?
So what's the difference? We have this thing called Special Protection Scheme for Olkiluoto 3. So whenever Olkiluoto 3 will be tripped from the grid, it's faulted in some way, there is a direct tripping signal to some, I think it will finally be something like between 5 and 10 industrial sites. And then within 0.2 seconds, so very fast tripping, 300 megawatts of load will be tripped from the system. So effectively it will be 1300 megawatt that the system sees. So that was the condition we initially said, that this large power plant can be connected to the Finnish system if we have this kind of protection scheme in place. And now we already have the tenders for such a scheme, and now we are in the middle of negotiating who are the parties that will be participating. So let's say some large industrial forest companies, they will be tripping their processes whenever Olkiluoto 3 is faulted. And then effectively this 1600 megawatt unit becomes 1300 megawatt unit by tripping load instantaneously. So that's a Finnish specialty. I don't know if somewhere else one has this direct tripping due to loss of one power plant, but that's something we are now doing in order to be able to cope with this very large nuclear power unit.
Next.
One question still about smaller scale nuclear reactors, since you better know the discussion atmosphere in the European expert level. Is there anywhere else in Europe that people are planning or dreaming about these smaller scale nuclear power plants, or is Finland somehow special?
Well, nuclear word is something you don't mention in the European scene. It's only us, the Hungarians, some other countries here at the east. But nuclear is something that people are not planning too much on. So it's something to get rid of. That's the European thinking. I don't know if it's wise or not, but it's very much directed through politicians and the general feeling of things, and that's the way it goes. But whenever we have some document and the word nuclear is over there, people try to mend it, let's say CO2 free or something, but let's skip the word nuclear because that's filthy in a way.
Other comments, please?
Where do you see the power generation going in the world now? Is it going to be more decentralized or centralized? And if it's going towards decentralized, what will be Fingrid's role, since transmission will be less needed?
Of course it will go more decentralized, that's the big picture. But then does it mean that you don't need any grid anymore? I would say no, because this decentralized production, it's fluctuating. So at some times you need all of the power from the grid, at some times you are pushing it towards the grid, so you still need the grid. But in case you are able to find yourself a good way to store energy locally, then of course you don't need that much of grid anymore. But as long as there is no place to put your electricity when you have excess of it, then you still need the grid, and then you need to take the electricity from somewhere when you cannot produce it locally. So the grid is still needed.
Please.
It's kind of a follow-up of the question from the young man over there.
Okay.
I'm thinking about if you have a very large grid.
Yes.
And you have the renewables, which fluctuate. The bigger the grid is, of course, the less the fluctuation will be.
So it blows somewhere, or yeah.
The sun is shining
Yeah.
somewhere.
Yeah.
What I'm wondering is what are the main hindrances in causing, allowing for as high transmissions as possible? What's sort of stopping the transmissions going from south of Europe to north?
For example, Germany, they have long had the problem that they are now closing the nuclear units down south, and then they are increasing the renewable production up north. But people are fiercely opposing any new power lines inside Germany. So that has created so-called loop flows. So Germany is using the grids of the adjoining countries, Poland, Czech Republic, whatever. So the power is going somewhere else. They are overloading their neighbors. And people are very angry about that. Why don't you build your own grid? But people are opposing. So there are still some projects which have been under planning for 20 years or so, and people are opposing fiercely. You don't build power lines into my backyard. So in the mid of Europe, you don't have the space for all the lines that you would need. You have the space at the sea. You can lay out cables between Norway and other countries. That can still be done. But when you try to go across the Europe, I think you don't find the places for the lines anymore. And cabling is not a solution because you still need to reserve that large space. You need to dig it into the soil. Nobody can build on it. So it's only, you don't see it, but still you need the right of way. You need the space for the line. So I think the main problem is where do you find all the space for these lines that would be needed? And then you end up, okay, we cannot build all the lines we would need. Yeah.
Any other questions? So it seems everybody's happy.
Yep. One more.
Given that the building of the grid is so slow, is there, do the market price signals from the market go fast enough to the production of new power lines and such, or would free market lead to only such a situation that it's acceptable to have some hours of generation inadequacy or something like that? So would you need more regulation to take account into the future changes, or how do you tackle that?
Yeah, in my mind, you would not need to build a system for every single hour. If you have a small probability, then let's live with that, of losing, of not being able to deliver every single megawatt. So you should be able to design your system in a clever way to find the optimal solution, the socio-economically accepted level of security. But so far we are missing the tools to do that, how to calculate the real value of electricity. And then you can optimize, okay, is it worthwhile building all these lines or all these power plants to take care of every single hour of the day? But I think that in the future you need to optimize. You cannot make the assumption that the system needs to be able to give you enough electricity every hour, because that's not the optimal solution anymore. It's way too expensive to do that. You need to base your assumption on some probabilistic approach where you optimize your system. I don't know if I answered your question, hopefully, yes.
One more question regarding the generation capacity. So even after Olkiluoto 3 will be added, so Finland is still, after that one, Finland will be still heavily dependent
Yes.
on imports. Currently, as we all know, it's 50 gigawatts after the consumption and the own generation capabilities about 10. So in your personal view, do we need more generation capacity after Olkiluoto 3?
Yeah, of course we need. So we are still heavily dependent on our neighbors after Olkiluoto 3. And even after Fennovoima builds their power plant, still we are importing electricity from Sweden. So we are doing the best we can. So soon we will start building a new line to Sweden up north, and it will be ready by 2025. And then we are planning to replace one of the existing cables to Sweden with a bigger one by 2029, if I remember correctly. But you cannot build your whole system based on import, because, as I told, the system it's an electrical machine. If you don't have any generators creating your voltage, you are not able to control the system anymore. So I would very much like to see some production, but it's the market signals. It's not some political decisions only. If politicians decide that we need this and that much of power plant, they don't have the money yet. So somebody needs to be able to make money out of the market, and that's the way somebody builds the electricity production sources finally. But of course, if we don't have enough production, then the price should go up, and then somebody builds it, and that's the way it stabilizes. It doesn't require any political decisions. You just let the price show.
But we have to go through the crisis.
Yes, hopefully not, but sometimes you need it.
Last possibility.
Yes.
So, any other comments? I think we had a very good presentation and a really good discussion after the presentation. And I think we have to give a good thanks, good applause to Jussi about this presentation.